The goal of this e-tutorial is to show how to create an animation. An animation defines a group of changes, the movements of the model, in a certain time range, so that the model behavior during such movements can be verified, and that an AVI file showing the model evolution can be created. Collision management is an integral part of the animation command and can be used to verify the movements of components inside the assembly, offering the capability to create a report of such collisions. Now, let us take a look at how to create an animation. Given this assembly in which the creation of an animation has already started, let's select Tools, Animation from the Principal menu. All parameters of the animation management command are proposed in this area, initially docked to the bottom margin of ThinkDesign window. This area can obviously be moved as if it were a toolbar, drawing it, for example, to another position, as we shall see. Moreover, thanks to this window type, we can simply work on our assembly in full screen mode, minimizing the window with the proper button and reopening it when needed. In the list on the left side of this window, we have all the animations that are on board of this model. As a matter of fact, we can create several animations for the same model or assembly. Here we have already started creating this animation by default called Animation 1, and in the meantime we can rename it, calling it, for instance, Assembly Animation. Now we can add new evolutions. Well, let's first rename our animation, okay, and call it Assembly Animation. We are ready to add new evolutions. What are evolutions? Animations are generated progressively, modifying the portal parameters within the tool limits, defining value and status in a certain time range. Any change of such parameters is called an evolution. Parameters can be of several different types. For example, dimensions or spreadsheet variables. Let's now examine one by one the different evolution types we can make use of. The one we are creating is of the variable type, that is an evolution related to a spreadsheet variable. The latter is automatically activated upon selecting OK. Let's, for example, select the variable on line 2 in the spreadsheet. Let's click OK and observe that in the evolution area of the animation command dialog box, a new evolution is created with the same name as the one of the variable chosen in the spreadsheet. Right-clicking on the box on the right of the new evolution, where we can define its variation, let's now choose New Variation in the context menu. This will enable us to define the behavior of the new evolution by assigning the chosen variable values through time. As soon as the blue area related to the variation of chosen evolution is displayed, let us right-click on such area and let's choose Edit Variation, which will enable us to modify it. The Edit Variation dialog box shows up. Let's set the starting time to 3:52 seconds and the end time to 3:67. Then let's set the initial value to 100 and the end value to 17. Let's confirm by clicking OK. Let's enlarge the window in order to better appreciate the whole model. We can now take into account the defined variation, right-click on it, and copy it using Copy Variation. After pasting, we shall edit the values and set them to 367 and 394 respectively, while the initial and final values will be respectively -17 and 100. Let's confirm with OK. And here are our two variations for the chosen evolution. Let's now take a look at another type of evolution, Another type of evolution can be based on driving dimensions. First, let's then make the needed dimension visible in the model. To do so, let us click the iconizing button of the animation command window. Then, from the model structure, let us right-click on the mating 1150 icon. Let us select Show Driving Dimensions, and this is the driving dimension we want to use. Using a zoom window, let us enlarge the area of the model where the dimension is visible, and let's reopen the animation window we had iconized. Let's add a new evolution by right-clicking again on the gray evolution area and choosing Add Evolution. In the dialog box, let us choose Dimension. Let us select the dimension in the model. Let's click OK at the request. And then let us click OK on top of the animation command selection list. The new evolution name dimension 1 has been added to the animation command window. Now we can rename it by right-clicking on the evolution name and by choosing Rename Evolution in the context menu, assigning it the clamp opening name. Let us now create a new variation by right-clicking on the area on the right of clamp opening and choosing New Variation in the blue area. Let us select Edit Variation and let's input the initial time of 1 and the final time of 2 to 3 seconds, and then the initial value of 0 and the final of 100 millimeters. Let us confirm by clicking OK. Before going on with the new evolution, in the model structure, let us activate the Layers tab and let us activate Layer 10 by clicking on the corresponding lamp icon. Let us fit the view and we shall see that on Layer 10 we have this component here, Lamiera. The starting part, which as we shall see during the animation, will be moved onto this other part and then cut by the blade. Let's then create a new evolution. Let's move the model upwards so that it be visible when we reopen the animation command window previously iconized. With a right-click on the gray area, let us create a new evolution through the Add Evolution command. Let's choose the visibility type and confirm with OK. We have to select the involved entities. The entity involved in the evolution in our case is the last used component. Let us then select it after renaming the new evolution and setting the new variation, remembering that this evolution indicates in which time range the entity will be visible by setting the start time to 204 and the end one to 362. Now let's add a new evolution of the movement, of the free movement type. Therefore, Add Evolution, and then in the dialog box which shows up, let us choose Free Movement. Let's confirm with OK. The free movement type captures the movement of an entity between two limit positions. The movement can be independent of any variable, and that's why it is called free. Then let us select the usual component and let us confirm it with the green button on top of the selection list. At the bottom of the evolution list, let us rename free movement to original movement. Now we've got to capture the starting position and the final one of our component. So first of all, let's insert a new variation on the original movement evolution, choosing Capture Start Position from Model in the context menu. Afterwards, we shall have to move the component in a certain way in order to be able to capture the final position. In the meantime, let's iconize the animation window and let us fit the model view, Then let us set a coincidence mating between the inferior face of our component as we rotate the model so that we can select it. You shall see. We are now going to rotate the model in order to select the inferior face of our component, and then click it, and the superior face of component clamp. Let us now perform a window zoom between the two faces we have constrained to coincidence, and then with the proper zoom let's set a coincidence mating between the external right face of the lamiera component and the internal vertex face of clamp. Finally, let us set a new alignment mating between the external face of component lamiera and the external face of clamp, the front face, with an offset of value 40. Let's fit the view of the model again. Now let us capture the final position. Let us get back to the animation command window. Let's right click on the blue area of original movement and let us choose capture and position from model. With this, the movement is defined. Beyond this, we shall also have to specify the time range. With edit variation, let us set the initial time to 204 and the final one to 352. As you can see. And confirm with OK. For the moment, from the Layers tab, let us hide layer 10. Let's now see also other parts of the animation command window. We have already seen that on the left we have the list of animations. A little more on the right we have the evolution list, and further the blue zones indicate the time range in which a certain evolution takes place. We have seen it can be related to a spreadsheet variable, to a dimension, to visibility, to a free movement, and so on. Below the evolution list, some buttons manage the graphics of the parts related to the evolution ranges. Below the evolution list, some buttons manage the graphics of the part related to the evolution ranges. A zoom in, a zoom out, a fit for that part of the window, a button enabling us to capture the start and the end of certain variations. As long as you're defining variations, being capable of capturing component position is very useful. And finally, a button which manages the time range during which the animation is performed. Suppose you have an animation lasting half an hour, but you're interested only in the very few initial minutes, then you can use this button to fix the limits of the part you actually want to watch. In the top zone of the window, we have the buttons used for the management of the animation movement. To send it back to the initial position, to make it go forward or backward step by step, or directly till the end position, with fast steps or with the ordinary animation play speed. With these buttons, we also have the possibilities to set the animation parameters. Therefore, the duration in seconds and the steps per unit, that is, the number of steps that will be created. The flag initial status of variation enables us to impose that the initial status of the first variation be reset anytime you use the left button on top, the one moving the animation back to the initial position. At such an extent, we can try to launch our animation using the play button after iconizing the window and unhiding layers 10, 21, and 22. As we are doing, and you can easily see in our movie.